Hello everyone. In this lecture we are going to study about the solution of linear homogeneous partial differential equation with constant coefficient. A learning outcome of this online lecture is one should be able to understand the following rule for finding particular integral for the homogeneous linear partial differential equation with constant coefficient. Pi for linear homogeneous partial differential equation with constant coefficient. A partial differential equation is represented as function of d and d dash, where z is a dependent variable, is equal to function of xy. Case 1, when function f is equal to e to the power ax plus by, or if we get e to the power 2a plus 0 e to the power 2x plus 0 y, that means a is equal to 2 and b is equal to 0, then pi is equal to 1 over f d dash e to the power ax plus by. We just replace d with a and d dash will be replaced by b. We get f ab e to the power ax plus by. Remember, denominator is never equal to 0. Once it is equal to 0, then it will be a problem. Then we will use the previous first unit method. That is, if denominator is 0, multiply by x, differentiate function f of d dash with respect to capital D, and again substitute the values in ax plus by, and again substitute the value in denominator. Now example, d cube minus 3d square plus d dash plus 4d dash cube z is equal to e to the power x plus 2y. Now this is the example. The auxiliary equation for this is m cube minus 3 m square plus 4 is equal to 0. Root of this equation is minus 1, 2 and 2. Then the CF will be f1. Remember, in a previous video, we said that this is the function phi1 is y plus m1x. Over here, a function phi can be represented as a function of f1. So we replace it with f1 y minus x plus f2 y plus 2x, and because the second root is repeated, so we multiply with x, f3 y plus 2x. Now for the pi portion, pi is equal to 1 over f d dash into e to the power ax plus by. Now d is replaced by as compared to over here 1, and d dash is going to be replaced by 2. So d is replaced by 1, d dash is replaced by 2. We get 1 by 27 e to the power x plus 2y. So the final solution for this problem is CF plus the pi portion e to the power x plus 2y upon 27. So this will be the final solution. Now, but if denominator is 0, when substituting the value of a and b, the denominator is 0, then pi is equal to, if fab is equal to 0, then we multiply with numerator by x. That means over here we multiply by x and differentiate the denominator with respect to capital D. That means differentiate with respect to capital D. Function of d dash is differentiated with respect to capital D, and e to the power ax plus by is same. Now after this we will substitute the value of d is equal to a and d dash is equal to b after the differentiation. Suppose the denominator is again 0, then we have to again multiply with x. That will be x square over again differentiation with respect to d of function f of d d dash and e to the power ax plus by. We have to do this work until the denominator is not going to convert into a number. If the denominator is 0, the result will be infinity. So we have to remove this problem by using this technique. Now consider example d square minus 2d d dash plus d dash square z is equal to e to the power x plus y. Now for the pi case, if we substitute the value of a pi over here, we find that when we substitute the value of pi, we find that 1 square minus 2 1 into 1 plus 1 square. So it will be 1 plus 1 2 and minus 2, denominator is 0 when we substitute the value over here. So we differentiate the denominator term with respect to x, with respect to capital D, and multiply with x. So we multiply with x, and this portion is differentiated with respect to d. We get 2d minus 2d dash, and differentiation of this d dash square is 0. So we get 2d minus 2d d dash. Again substituting the value, we find that it is equal to 0. So we again multiply with x, then the x is equal to x square. The numerator x is converted into x square, and differentiating this term with respect to d, we get only 2, because differentiation of d dash is 0, because d dash is a constant, and differentiation of this term is equal to 2. Now finally the pi is x square upon 2 e to the power x plus y is the pi. Now continue by second case, when fx right side value, because the partial differential equation is f d d dash z is equal to function of x and y. The first case is when function of x and y is e to the power ax plus by, and the second case is function is equal to sine ax plus by or cos ax plus by. In this case, the function is represented as d dash square, d dash, and d dash square, d square, d dash square. So these values is going to be replaced by d square is replaced by minus of a square, d dash square is replaced by minus of b square, and d into d dash is equal to minus of ab. We have to replace these values in a denominator, and remember the denominator case, denominator is never 0. If it is 0, then denominator will be differentiated with respect to capital D, and the solution is according to the function is replaced by d square is replaced by minus of a square, d into d dash is replaced by minus of ab, d dash square is replaced by minus of b square for sine ax plus by, or the function is cos ax plus by. Now considering the example, d square plus 2d d dash plus d dash square z is equal to sine 2x plus 3y. Now according to this, d square is going to be replaced by minus of 4, d dash square is replaced by minus of 9, d into d dash will be replaced by minus of 6. So we replace the denominator, this will be replaced by minus of 4 square, minus of 4, minus 4, 2 into d dash is replaced by minus 6, this will be minus 6, and d dash square is replaced by 9, so it is replaced by minus 9. So denominator is minus 25. So finally the pi for this problem is this. Remember, you have to find out the CF also. If the problem is in the examination, solve the given differential equation, first you have to find out the CF, then you will go for the pi portion. But if the denominator becomes 0 in a similar way, then the same thing will be happen. multiply with the denominator with x, multiply numerator with x, and differentiate the denominator with respect to d. Now consider the example. If it is equal to d square plus d dash square minus 6d dash square is equal to cos 2x plus y. That means d square is replaced by minus of 4, d dash square will be replaced by minus 1, and d into d dash will be replaced by minus 2. If we replace with these values over here, we get minus 4 and minus 1, that will be minus 5, minus 4 and minus 4 and minus 2, minus 4 and minus 2, it is minus 6, the value is minus 6, and we substitute the value of d dash square as a minus 1, it will be plus 6, so denominator is 0. So we multiply with x and differentiate this denominator with respect to d. Then we get the differentiation of d square is 2d, differentiation of d dash is equal to d dash only, and x is multiplied on a numerator side, and cos 2x plus y. Again, because d and d dash is d is stand for d by dx and d dash is stand for d by dy, but in a cos and sine we have to replace the values according to these d square in a power of 2, so we multiply it with d in a numerator as a denominator, d is multiplied on the upper side and in a denominator, so we get 2d square plus d dash. Now again we substitute the values over here, we get minus 10, x is same, and differentiation of cos 2x plus y with respect to x. When we differentiate with respect to x, we get x over minus 10 is same, x over minus 10 is same, differentiation with respect to x, that means cos is converted into minus of sine 2x plus y, and multiply with this 2. So finally 2 is cancelled, so finally we have the solution x by 5 sine 2x plus y. Now continuing for the third case, if the function, right side function is in a form of ax plus by, a function in the form of ax plus by, that means a partial differentiation of f d dash into z is equal to function of x y is actually in the form of ax plus by, then f d dash is homogeneous function of degree n, that means all the terms in the f d dash is having the same power, and f a b is not equal to 0. When we substitute the value of d as a and d dash as a b, it is not equal to 0. Then the pi is 1 over f d dash, 1 over f d dash into phi of ax plus by is equal to 1 over fab, that means we replace the value of d as a and d dash is replaced by b, and integration of phi of u dx, multiple integral of nth order, that means the power of n d, if the power of d is 2, then we have to integrate twice over here, that 1 over f of ab and double integration of phi of u du, where u is equal to ax plus by. Now considering the example over here, d square plus 3d dash plus 2d dash square z is equal to x plus y. Now it is a function of ax plus by, like this, in this form. In this form it is a function, so this function is in this form. Now for the pi, the all terms in the denominator. D square, d dash, d dash square, all are having the same power, so it is a homogeneous function of degree 2. The value of d is 2. Now d is replaced by, as per this comparison, d is replaced by 1 and d dash will be replaced by 1. Denominator is this, and the complete function this is equal to u. X plus y is equal to u. Because the power of the d is 2, so double integration, so the double integration of u du. First time integration of u is square by 2, and again the integration of this part is u to the power 3 by 6. So the value will be 2 into 3, 6. Yes. Now we substitute the value over here. U is again replaced by x plus y. U is replaced in terms of x plus y in the final solution, and the portion of this is calculated 1 by 6 and again 1 by 6, u cube upon 6. So finally the solution is x plus y whole cube upon 6 into 6, that is 36. So this is the PI in this case. Now summarizing this lesson. In this lesson we have discussed about the following: case of homogeneous partial differential equation with constant coefficient, CF case, and PI case. Over here we discussed the PI case actually. PI case and 3 cases of particular integration. Thank you. For any doubt and any query, contact your concerned class faculty and subscribe this channel for the upcoming videos. And stay home, stay safe.